Under 6.6, we are told that we can solve problems involving velocity and time using vectors. And one main point that we have been informed is that if a particle starts from the point with position vector r naught rather, and moves with constant velocity v, then its displacement from its initial position at time t is going to be displacement is going to be vt, and its position vector r is given by ro plus vt, r naught plus vt. This is just what we know. Because if you want to get the position vector, for example, if you're driving from Nairobi all the way to Mombasa via Voi, and then this is Mombasa, your position relative to Nairobi will always be, if you want to consider when you are at Voi, and probably if this is 0 kilometer from Nairobi and this is 300 kilometers from Nairobi, and you would want to, and the distance between Voi to Mombasa is 100 kilometers, then the moment you arrive at Mombasa, you will talk about r, which is your position vector, is going to be equals to r naught, which is 300 when you started considering your movement, plus the distance covered, 100, and you will now be, r will be 400 kilometers. So your position relative to Nairobi will actually be 400 kilometers. That means Mombasa is 400 kilometers from Nairobi. So we need to talk about the position vector. The position vector is going to be the initial position, which is this is r naught plus the distance covered, which is vt. We must always remember this. This is the position vector, or the position where you are, is going to be given by initial position, where you are starting your journey from. You add the distance and you will be talking about r. So example 12 is going to use this piece of knowledge, and we are asked a particle starts from the point with position vector 3i starting, so r naught is 3i plus 7j, and moves with constant velocity of, so v is 2i minus j. Of course, the velocity is meters per second. Find the position vector of the particle 4 seconds later. Find the position vector of the particle 4 seconds later. Now, the position vector is, you are supposed to first of all get the displacement. What was the displacement? Displacement is going to be the velocity times time, which is going to be 4 multiplied by 2i minus j, which is 8i minus 4j. So that is the displacement, which is vt. And then the position vector, this is the position vector, which is r now, is going to be r naught, the starting point, 3i plus 7j plus the displacement vt plus 8i minus 4j. And this one is going to give us r is going to be 11i plus 3j. j, 11I plus 3j. All right?